Hello, Statistics 215 students. I wanted to prepare a short video to review how to use your calculator to answer questions about the normal distribution. So let's look at some sample problems here. So here's a sample question that uses the normal distribution. High-density lipoprotein, or HDL, is sometimes called good cholesterol. There's good cholesterol and bad cholesterol for those people of my age who need to keep track of those things. HDL is good cholesterol because high values are associated with a lower risk of heart disease. U.S. women aged 20 and over have a mean HDL of 55 milligrams per deciliter and a standard deviation of 15.5. Assume that the distribution is normal. We're going to answer some questions based on this information here. Question number one. The American Heart Association says people over age 20 should have an HDL level of at least 40 milligrams per deciliter. What percent of American women have an HDL level of at least 40 milligrams per deciliter? Well, I think almost any instructor would highly suggest you start with a picture, and many instructors like myself will make that part of the problem. So what sort of picture should we start with? We should start with a picture of a normal distribution, a distribution that is symmetric, bell-shaped, and unimodal. The mean should be marked in the middle. So we remember, given in the text of the problem, the mean for this distribution is 55, and the mean of a normal distribution is always underneath that peak. Now, if you want to mark off the standard deviations, that's fine. Our standard deviation in this problem was 15.5, and that would give me a scale. I can mark up to about this point where the curve starts to change its shape a little bit. If I go up 15.5 units and down 15.5 units, I can set a scale here. The important point to mark, though, is the one in the question, 40 milligrams, or an HDL level of at least 40 milligrams. So let's mark that 40. Let's make sure that that is clearly marked there. And let's think about what that means. At least 40 means 40 or more, right? At least 40 means 40 or more. So we are looking for the HDL scores that are above 40. So this is the shape of the graph. One reason we ask you to draw these graphs is to help you get an idea of the shape of this region, because the area of this region is the answer to this question. What proportion or percent of data falls within this region here? So drawing the picture will help us with those values there, and it helps us get a rough guess of what this value is going to be. I think this value is going to be well over 50%, because well over 50% of my curve is shaded in here. So we will use the normal CDF command on the calculator to help us answer this question. We notice we've got a lower boundary of 40, and this extends to forever on the right. And we've got a mean and standard deviation was given to us in the problem. So now we are ready to go to our calculator and put in that information. We'll need to put in a lower bound, an upper bound, a mean, and a standard deviation. So let's see what that looks like on the calculator. So let me switch to my calculator view. So where do we find these options on the calculator? They're under the distribution button. So if I go to second and variables, right underneath those arrow keys is the distribution button there. And we want the normal CDF button, the new normal cumulative distribution function button. And as I hit enter here on my model calculator, it gives me a few options here. So whether you have the newer model of calculator or an older model of calculator that doesn't have this middle screen, you always want to put in the lower edge of your region. As we graphed that picture and we looked at the shaded region, the lower or left edge of that region was 40. So I'm going to type in 40. The upper edge, this seemed to stretch on forever. And so we'll put in what the calculator considers a decent representative of infinity, or at least as large as the calculator can handle. So I'm going to put in 1 E99. So E is right above that comma and then 99. So this is your calculator's version of 1 times 10 to the 99th, which is about as big a value as your calculator can handle. It's a good proxy for infinity here. Now, in problems involving the standard normal distribution, leave your mean at 0 and standard deviation as 1. Again, for the standard normal distribution, you see that special word standard in front of normal distribution, leave the mean at 0 and 1. But for this problem, they gave us a different mean and standard deviation, didn't they? If you need to rewind the video and go and reread the problem and look those up, that's fine. For us here, I'll go ahead and give us our mean was 55 and our standard deviation was 15.5. So there's our mean and standard deviation. And then when I hit paste, it'll type this into my calculator. Again, if you have an older model of TI-83 or 84, you may just see this screen and need to type in the 40, the 1E99, the 55, the 15.5 for yourself on this screen. Once we've got everything entered here, we hit enter again, and it's going to give us a value for that probability there. So that is a 0.8334. And so let me switch back to my paper to show you how I would ask my students to record their solution here. So I would ask my students to tell me everything you just put in that calculator, the normal CDF, and then tell me the things you put in here. 40, 1E99 for this region that starts at 40 and stretches out forever on the right. And then we put in the mean of 55 and the standard deviation of 15.5. And then we got back to 0.8334. If your problem had said proportion or probability, we would stop right here and leave the decimal version. Some books might even say, for this problem, we were looking for the probability a value was greater than 40 and would leave our answer like this. This problem instead has asked for a percent. And so we will simply convert that proportion or probability to a percent by moving that decimal 2 places. So 83.34% of women have an HDL level of at least 40 milligrams per deciliter for our answer to this one here. All right, let's move on to question number 2. And again, now we've seen the calculator can do parts of this question, but there are some things that we need to do for ourselves. Find the percent of American women with an HDL level between 40 and 60 milligrams. The calculator is not giving us a picture here. So again, of my students, I would require a picture marking the mean, which again was given to be 55 in the middle. If you want to put in a scale, what am I doing for my scale? I am adding and subtracting the standard deviation. I'm adding and subtracting 15.5 here. But what's really important is to put in these values that we're looking for here between 40 and 60. So let's put the 40 in here. If you have trouble putting these things in, remember x-axis acts like a number line. So 40 is close to 39.5, but a little bit bigger. 55 to the right, and next value is 60. It's a little bit bigger than 55, but not quite up to 70.5. So here's my 60. And so the region I'm looking for now is this region right here. So I would expect this final answer to be significantly smaller than the last one, right? Because the last one included extremely high HDL scores. This one's going to stop at 60. So I expect this value to be quite smaller than the last one. Also, it's going to help me set up my calculator command. So again, normal cumulative distribution function is the command we want from the calculator. And we can already write down what we're going to put in here, right? We have 40 for our lower or left boundary. We have 60 for our upper or right boundary. If this problem had said standard normal distribution, we would use mean 0 and standard deviation 1. However, they gave us a different mean here, so we should input that here as well, 55 for the mean and 15.5 for the standard deviation. So this is the command we will put into the calculator. Let's review one more time how to actually put that into our calculator. So again, a reminder, these commands that help you with the normal distribution are under the distribution button. So I hit second in variables, the distribution button right beneath those arrow buttons, and I choose the second one down, normal CDF. And I put the values in here again, 40 for my lower bound, 60 for my upper bound. My mean and standard deviation are here from the last problem. So mean of 55 and standard deviation of 15.5. And there are my 4 values put in there, and let's hit enter for it to do the calculation for us. And we get 0.4599. 0.4599. So again, to finish off the problem, what we see is we should say that this value is equal to 0.4599. And again, sometimes this problem will say proportion or probability. What we've really done here is say, what is the probability that a value is between 40 and 60? And you might see this notation, probability of values within the range we've got between 40 and 60. If you are talking about a probability or proportion, leave it as the decimal version, 0.4599. This problem asked for a percent. And so we can interpret this as a percent by moving that decimal 2 decimal places and say 45.99% of who or what were we measuring? Women. Which quality of those objects or people were we measuring? 45.99% of women have an HDL level. That's what we were measuring. In what range? Between 40 and 60 milligrams per deciliter. All right, let's do one more example. And this one is a little bit different from the others. So let's read carefully here. Doctors recommend medicine for women whose HDL levels are in the bottom 10%. Find the HDL level such that only 10% of American women have a lower HDL level. Well, before you begin, I strongly suggest a picture. Your instructor may make that part of the scoring of the problem. I would typically do that in my class. Let's again mark that mean in the middle. And if you want to mark a scale of subtracting the standard deviation and then adding the standard deviation, that might help us get this to a good scale. But notice what's different here. In the previous problems, they gave us boundary values to tell us where to start a region, or maybe both where to start and end a region. That's not what we've got here. We want to find the value for ourselves. We need to find that boundary value for ourselves. Which boundary value? The value that marks the bottom 10%. The boundary that marks the bottom 10%. So what I'm going to do is shade in about 10% of this graph on the bottom end. So bottom 10% might be this much. That might even be a little bit ambitious for 10%, but there's the bottom 10%. And I'm going to use the decimal version here, 0.10, because in formulas and calculator speak, we need to convert those percents to decimals, 0.10 for 10%. So I need the boundary value that says, here's where I stop so that this region will be 10%. It's almost the reverse of the problem we did before, right? Before we were given boundary values and we got a proportion or percent. Here we have the proportion or percent and we want to find the boundary value. This means we need to use the inverse norm command. The inverse norm command will help us with this. So let's go look at this on the calculator together. So as I switch to my calculator screen, the good news is the inverse norm command is in the same place our normal CDF command was. I go to variables. Second variables to get to my distribution list. And 1, 2, 3 down on my calculator is the inverse norm command. And here on the inverse norm command, they want the area. So here's where we look at that picture. We wanted a picture that had the bottom 10% shaded in. So we'll use 0.10 for the bottom 10%. 0.10 for the bottom 10%. If this problem is talking about the standard normal distribution, and you'll see standard in front of normal distribution, use the 0 and 1. However, if they give you a different mean and standard deviation, you should change that in this problem. Here, we were given a mean of 55 and a standard deviation of 15.5. Now, on my model of calculator, it gives me a choice. Do I want to look at the left end of the graph or the right end of the graph or the middle of the graph? Here we shaded the far left end of the graph, didn't we? We shaded the far left end of the graph to represent the bottom 10%. So I want to shade to the left. If you have an older model of calculator that doesn't have this line here for left, center, and right, your calculator is automatically by default doing the left tail, the left tail. So you might want to convert things like the top 10% corresponds to 100 minus 10 would be the bottom 90%. Convert everything to a bottom percent, bottom 10%, so you can use the left tail option. So here, let me paste these things back in. And so now I've got in there my area, I've got in my mean, my standard deviation, and my direction, and I will hit enter for it to do the calculation. And it tells me 35.14. Let's round it off there. 35.14 for our answer here. Let's go back to our paper to show you how I would expect this to be answered on an exam or assignment. You are going to tell me which command you're using. So instead of normal CDF, like the last problems, you're telling me you're using the inverse norm with all the values, the area or proportion. This time it's the percent converted to a proportion. The mean, which was 55, the standard deviation, and which direction I shaded to corresponding bottom 10% was to the left. And then the value I got here. We should put a label on this. These values were in milligrams per deciliter. And if we want to be a little bit more particular about our answer, we could say something like a HDL level of 35.14 milligrams per deciliter marks the bottom 10% of women's HDL levels. And there we go. There's a quick review of some normal distribution problems and how to use the inverse norm and normal CDF buttons on your calculator to help you answer those questions.